Hello and welcome to the last video of this series about wind. And here I would like to discuss what is the Wind Atlas method, and then we have a look to the European Wind Atlas, how we get data to different sites for wind behavior in Europe. In Europe, these wind assessments are almost always prepared according to this Wind Atlas method, insofar as no measurements are available for a certain site where you are interested to build a wind turbine or a wind park. And the data in this atlas is based on over 200 measurement stations with long-term data at a typical measurement height of 10 meters. So typical heights that we also find in airports, for example. Then the regional wind climatology is determined from the raw data of the measurement station using the geostrophic friction law. And in the first step, we take the measurement data and the obstacles are calculated out of this measurement data. So obstacles like buildings, trees just around the measurement station. In the next steps, we are calculating out the roughnesses of this specific site. So we are calculating if we have a completely plain area. And in the third step, we are calculating out the orography. That means whether we have a hilly environment or whatever. And by that, we receive then viable parameters for regional distribution of an area of approximately 200 times 200 kilometer area. That is for that area, but without considering any obstacles, any roughnesses, any orography. And in the next step, then we use the Wind Atlas Analysis and Application Program, short WASP, and with that we determine the wind data for specific potential site for a wind turbine or a wind park. The procedure is a reversal of the calculation of the regional data from the underlying local raw data of the measurement station. And the suitable new wind data are calculated from then a nearby wind measuring station that is not so far away or too far away from where we want to build our wind park via the regional wind data. And for these, we calculate the new framework conditions with the existing orography, surface roughness, and the shading by obstacles, and get then a quite good set of data with which we can make the calculations for our wind turbines and wind parks. Now we would like to have a look into this European Wind Atlas. And on the first page, I just have taken here the example of List, Sylt, a German island in the North Sea. And the first is just a description of the measurement station itself. And there we get the location parameters, how high it is above sea level, and so on. And the table below describes the site of the measurement station. And in the left column, there we see the sectors from 0 to 330 degrees. 0 is always north, then 90 is east, 180 is south, and then we are going backwards to north. And then we see first the roughness length. In the sector 0 it is 0.1 meters for 2,700 meters of distance. That means the next 2.7 kilometers we assume here a roughness length of 10 centimeters. Then we have a conversion in the roughness length going to 0.01. That is, I think, on this island is just sand, until a distance from the measurement station of 5.4 kilometer. And then we have another break in the roughness, then it's 0, what is then just the sea. And that we get for all the direction, that we know how is the surrounding around our measurement data. The next what we have is a table describing the measurement data. Again, we have it for all the sectors from north, east, south, and then going by west again to north. The second column, we have the frequency of this orientation. And then in the biggest part, we have just the frequency of the measurement data itself. So the first one is between 0 and 1 meter per second, then 1 and 2 meter per second, and the last one, those occurrences that are bigger than 17 meter per second. And in the complete right, we see then just A and K. We see the two Weibull parameters for each sector. And when we look to the complete lower right, we have the Weibull parameters for the measurement station at Sylt in this location, where A is 8 meter per second and K is 2.15. Then we also have a table that describes the behavior depending on day of time and time of year. That means we have on the vertical, we have the time starting at midnight, then 3 o'clock, 6 o'clock, 9 o'clock, and so on until 9 p.m. in the evening. And then on the horizontal, we have from January to December all the months. And then we have the means over the year according to day of time, and also the means per month. And what we can see here is quite a typical behavior of a site, the wind behavior of a site in Central Europe. When we look to time of day, it's not really a big variation, but we always can see a slight higher velocity in the early afternoon hours. And what we also can typically see for a region in the Northern Sea area is that we always have a bit lower wind speeds in summer months, and then it's increasing by autumn and winter, where we have higher wind speeds and higher powers available for wind turbines. On the right side, the next side of the atlas, they have done already a lot of calculations for us that we do not need to do anymore. So we have one table for the roughness class of 0 that corresponds to the roughness length we see on the right side. And then they have done the calculations for a height of 10 meters, 25 meters, 50, 100 and 200 meters. We have that again for all the sectors from 0, 30 until to 330 degrees. And then we see always two numbers, and always the numbers just mean our Weibull parameters. So it was good that we have dealt in other videos with the Weibull distribution, because all the wind speed is just expressed by those two numbers. And what we get then on the complete right is the Weibull parameters for different heights, the average over all the different wind directions. And then we just repeat the same in the lower table for the roughness class number 1, but the information is the same. And then we have the roughness class 2 and the roughness class 3. And that finishes with this small table where once more we have the different heights from 10 to 200 meters. And again, we have the roughness classes 0 to 3. And then for every height and class, we have the left number, that is the mean wind velocity we have there. And the right number is the power density in watt per square meter. That means how much wind power we have in average on 1 square meter of rotor area. And with that discussion of what we can find in the European Wind Atlas, I would like to finish that video series on wind behavior. So thank you very much.